Okay, for people who are joining us, this is a late-breaking item for version 12 of Wolfram Language. This is about NBodySimulation, and it's a kind of an experimental function for doing NBodySimulation, as the name might suggest. Okay, so we're going to review this documentation and so on. All right, so why is there a separate page for NBodySimulation data? Represents the results of an NBodySimulation. That's reasonable enough. Shouldn't this also say interpolating function? Actually, should it say NDSolve value rather than just NDSolve here?
Well, it actually uses NDSolve, but it could say NDSolve value.
And interpolating function.
Yes, I think that's appropriate.
I think also these things. Another one that is it in any way related to system model plot?
Not that I know of.
Okay. All right. So why is that in red?
I don't know. That's a bug that showed up this morning. I have no idea why when you put in 3 associations as rules, it's giving a syntax coloring error.
Okay. All right. So that's just a bug of today. Okay. Notice also that the font is wrong. Sushma, if you can note that in there, see that in that error message there, that font is wrong.
Okay. Yeah.
Okay, so let's take a look at what this actually does. So, simulate a 3-body problem in 2 dimensions. Is that a okay? Is this the simplest case, or can you give?
I could just give 2 bodies, but
that's rather boring.
Yeah, so 3 bodies is pretty much the simplest case then.
Yeah. Okay. All right. So let's take a look here. Why is it B? Oh, I was reading it as BAS N1. Okay, so
maybe it should just be SSN1 or something like that.
With names B sub I. So you can't give a list here. It has to be an association. Is that true?
It's a list of associations.
No, but I understand. But can the names can this outer thing be an association?
I can't honestly remember if I made that work or not. I mean, we certainly could do that.
It will be good to have that work, I think. Now, also, if you don't name the bodies, can you just have a list of associations there?
Well, you need some sort of body names, but yes, we could make that work where the body names would be
1, 2, 3.
Index numbers. Now, I avoided having just index numbers for the body because, like in that first example, we give a time t equals 4. Well, we also part of the rules is if you give data of, say, quote B1, it gives all the data for body 1 in terms of interpolating functions. So there's a possible ambiguity between a time and an integer index.
Ouch.
Right. That's why I changed to use these string names.
I think that's not great, because I think that one would like to have be able to have any number of bodies here. These are nice examples.
Well, thank you. This is sort of the ones we'd set up when we did the initial review on this.
Here, by the way, you shouldn't use, in these examples, you should use the actual entity. I don't see why you should write it out as entity like this. And also, you really shouldn't use, you should just use the thing that you get by doing, look, oops, why doesn't that do it? That you just get the thing that is, I mean, if you do evaluate in place for that, right?
Oh, fine. Okay.
Similarly here, I don't really see the reason why you don't just do evaluate in place.
I didn't. I just don't think that way, Stephen. But yes, you've got a good point.
Right. I mean, it doesn't help to. It doesn't really. No. Okay. Great. You should probably pull out some actual result here that is less trivial than just showing that. If you look at my blog post about the eclipse, there are a bunch of coordinate systems and things where you can actually see all kinds of interesting things about the Earth-Moon distance, for example.
Okay.
I mean, for example, I'm sure if I do this, if I compute this, let's try running this, in fact. I would imagine what I can do here is to take the distance from the Earth to the Moon, right? Position. I mean, like, for example, just the Earth-Moon distance.
Oh, sure. That's a nice idea. Yeah.
Right. So what would it be? Just norm?
Should just be norm. Though I'm not sure the norm works with the units properly, but
I certainly hope it would. There we go.
Lovely.
It's a pity that those things collide. Oops, function of time. Okay, so let's review again stuff up here. Okay, so properties given in association names piece of I. Through time t. Okay, fine. Seems okay. Okay, gives results. Gives results in terms of gives an NBodySimulation object as a result, right?
Yes.
We don't tend to do that way. We say an association, not. Why don't we give these first? Named. Wait. Possible named potential laws include. Well, possible named laws what is gravitation? Newtonian gravity, right?
Right.
So inverse square law with what parameter? Newtonian gravity with the gravitational constant?
Well, with the inverse square law, it just takes, it's basically like G equals 1.
Okay. With gravitational constant.
Yes, that the gravity uses a gravitational constant.
Coulomb's law with does that use with electric?
Yes, it uses electric, and you have to specify a charge for your bodies.
Okay. Okay, Coulomb's law with physical charges.
Mm-hmm.
What is the force? Okay, so what are the units for these things? Potential force laws may be given as named law, a function, or an association. Okay, so if it's a function, what do you give it?
If it's so you give it. See, this was a part of the whole thing we worked out. So we give the oh boy.
Well, it's not documented here. So
Right, it's not documented.
Okay, so we need to figure that out.
So I need to write that down. It's basically you give the you give a function where you put in the like you do pound one of mass, so you should use the body properties in the body of the function with the arguments are the two bodies.
Okay, possible named. Okay. So I'm sorry, but what are you saying here?
So you would give something like, so say you wanted to do the inverse square law. You'd give some for the potential. You give something like slot 1 of quote mass and slot 2 quote mass.
Okay, hold on. We're also going to say okay.
So the associations
wait.
or the
When names
arguments.
of bodies, just a minute. When names of bodies are given as entities, such as control equals. Whoops, is that not working? Control equals. Oh, fascinating. Such as that, right? Such as Earth. Properties such as mass are determined automatically.
Yes.
Okay, so what you're telling me is that then what the minimal case here that I can do will be something like I will be able to say NBodySimulation of gravity, comma. So can I just do this? Earth, comma, moon. Does that possibly work?
Well, I don't have. No, it doesn't work because I haven't. That would be a whole development project to try to get. So when do you start? You start with the current data. What are your initial conditions?
Okay, fair enough.
That's why that example was so complicated, because I had to sort of get initial conditions.
Okay, so here I could say position, arrow. I see what you're saying. Right, so it's not completely obvious what that does for us.
Right. Well, that's what that example did. And in fact, I think I had to sort of do an estimate of velocity from because it wasn't clear for me how to get it from the entity framework directly at the velocity, the orbital velocity at any given time.
Right. Someone's commenting on a live stream. They need to specify one of them. No. If you want both gravity and Coulomb's law, you need to give a combined. You need to specify that separately. We're not letting you give the physical properties. I mean, arguably here. This is a bit confusing because, okay. Using electric charges. Okay, so inverse square doesn't use mass, does it? Or does it use mass?
Yes, it uses mass.
Okay, so does harmonic use mass as well? So everything uses mass for inertia.
Right.
And inverse square and gravity use mass for the coupling, for the strength of the force as well. Is that correct?
That's correct. Yep.
Okay. So first of all, Okay, so this is a time. Wait a minute. What is this? So this is, where's the initial condition being given?
That's you give position and velocity, and that's the initial condition.
Okay. Yeah, someone's commenting on the live stream that looking up the orbital elements would be a good thing. We agree. Okay, so let's start this from the beginning again. Okay, so first of all, I think we should say law because it's a single law.
Well, yes, in the simplest case, but it can be a combination of things. So you could give an association with a bunch of laws.
I understand.
You could give a pairwise potential and an external force.
Okay, all right. Simulates a system of n bodies with names BI and properties and initial properties. Well, and properties comma governed by system of n bodies for time t. Simulates for time t. Well, we should say generates a simulation of the motion of a system of n bodies with names and properties given a it's a simulation of the motion of a system of n bodies governed by the specified potential or force law over the course of time, over at the interval of time t, over a length of time t. Okay, so the very first thing to say, okay. So the potential or force law can be given in the form, or force law can be given as, and now we need to, I think, give a list of the cases here, which are quotes name, named law. Then we need to say an association here. Basically, key one, arrow. Now, are those functions or names?
They're typically going to be functions.
Law with specified properties. Well, we might as well just say prop one. Okay, and now the third case is a function to be applied to configurations. Is that correct? What does that function do?
Well, so in the pairwise, so for each of those, and maybe we should put, the pairwise potential and describe what the function looks like then. So the function basically takes as arguments the associations for the two, for example, in the pairwise case, it takes the associations.
But can you give a single naked function as the law?
Yes.
Okay, what is it applied to then?
Well, it depends. That's what I'm trying to say. So in the pairwise case, so pairwise potential and pairwise force, it's applied to the associations for the two bodies involved.
Okay, I understand what you're saying, but I'm saying this is an alternative for the whole potential or force law. Okay? So is it the case that you can give a function as the complete thing, not an association that says pairwise potential arrow whatever, but a function, this first argument can be, a function?
The function, if you only give a function, it's interpreted as a pairwise potential.
Okay. Okay. Okay, fair enough. Okay, so now possible named laws include, and now they're these. Okay, I think we should give the harmonic potential next after this one.
Sure, okay.
Okay, inverse square law with unitless inverse square law. Is that a fair statement? Yes. And then unitless harmonic potential.
Mm-hmm.
Newtonian gravitation with units. Coulomb's law with units. Okay. Now, with physical units. You say physical units?
I think that's reasonable.
Okay. You know, is there still time to change this to Newtonian?
Sure. Sure, we can easily change that.
I think it's better since it's a pity that Newtonian harmonic inverse square. Okay, fine. Newtonian.
So you're just going to call it Newtonian, not Newtonian gravity.
I think so. It's a Newtonian potential as opposed to a Coulomb potential.
Okay, fine.
Okay. When the law is, the following keys can be used when the law is given as an association.
Now you called them
pairwise potential function. No, that's okay.
Okay.
Pairwise potential function between any two bodies.
Mm-hmm.
So what is that pairwise force function between any two bodies? Potential function applied to all bodies, is that correct?
Yes.
No, potential function applied to each body. Additional potential function applied to each body.
Yes.
Okay. Okay, so now what are these functions? Force and potential and force functions. Okay, so pairwise potential functions are applied to the association. Is it list?
No, the arguments they applied to the two associations. So you could put, I mean, you might want to put just pairwise functions are applied to the associations
Well, pairwise potential or force functions, or force functions F, are applied to the associations we usually say a sock here.
Okay.
Are applied as F of a sock I, a sock J, to the associations representing the states of bodies I and J. Is that correct?
Yes.
Why don't we say in states given in a sock? Right?
Yeah, that's better than properties.
Should we not name it a sock, but name it state 1? Body 1 arrow state 1? I think that would be much clearer.
It would be clear.
Then that's a good reason to do it.
Okay. We just want to make it clear that they need to be associations, though.
Given and states state I given as associations with names body I and states state I given as associations. You know what? Let's not say that. Governed by the specified potential force law over the length of time, because we can say the state sub I, okay, gives as the names of bodies are typically strings. Well, not necessarily. No. The states, state I, are given as associations. And what about the position? Yeah, okay. Given as associations containing the following elements. And then we can, and now charge is optional, right?
Yes. And you can also give, other elements, depending on your force law, you can put in whatever elements you want.
I see.
You could put containing elements including the following.
Well, are any of them compulsory?
Mass, position, and velocity are compulsory.
Okay. Then let's leave out charge here.
Okay.
Well, okay. So no, are given as associations containing the following elements. Additional elements used by particular potential force laws can also be included.
Yes.
Potential force laws can be given as possible named laws include following keys can be used when giving okay, pairwise potential or force functions F are applied applied at each step in computing the and are applied at each step given a pairwise or potential force function F is applied at each step in the computation to you see what I'm trying to say? Because we want to show this F of state 1, state I, state J.
Yeah, but using step is a little, it's actually applied
okay.
more than that. But
Okay. Pairwise is applied to all pairs. It's applied for all pairs of bodies I and J in the form.
yes.
We should say something about how the units have to make some sense. Okay, so okay. N-body simulation. Let's see. What you're trying to say, it's got to have the initial conditions here. Actually, why don't we just say an initial state, state I?
Yeah.
Okay. Now let's look at what you say for N-body simulation data, because that's where you're extracting the state.
Right.
Okay, wait a minute. The values in the states of each body can be given as quantities with units. Can I suggest that we might start with like something super simple, like a harmonic oscillator here? I mean, it's nice to start with a 3-body problem. By the way, is this thing with entities, does it really help us at all, or is it just a total mess? I think we should futurize that because I think it's too complicated. I think
right. Okay.
It's amusing that it works right now, but okay. So let's try and understand what would happen if we were just doing N-body simulation of. Okay, so now let's say harmonic. By the way, this needs auto-completion. Harmonic. Okay, so it's a little bit awkward that this business with it not. Okay, so let's take a look at this. So how do I give the spring constant for the harmonic potential?
You would use something like list of harmonic comma spring constant.
Great, you didn't tell anybody that.
No, I know. That's
okay. So in the case of in these cases with unit in inverse square and harmonic, unit multipliers, well, inverse square what is it called?
you call it the inverse square constant, or
harmonic by default uses, well, we could specify this. Is it the case that harmonic? Okay, so are you then saying harmonic, comma K, harmonic potential with spring constant K? Is that correct?
Okay, no, it works a little bit differently than that. So what you do is you'd give list of harmonic, and then you give option. So any of these things, they were set up to do options. So you do harmonic, list of harmonic, comma, then spring constant goes to whatever. And then that also has an option, equilibrium length.
Okay. By default, harmonic uses unit spring constant and unit equilibrium length.
Well, it actually uses 0 equilibrium length. Should I change that to unit?
What does equilibrium length mean then?
Well, it means you start with the 0 length spring and you stretch it out.
Okay.
From 0 length.
All right,
but I think unit length would be okay too.
Spring constant 1 and equilibrium length 1.
Okay. I will change that right now, in fact, since I'm looking at the code.
Okay, so this is the case where you can say harmonic and then you can give a specification here. Is that true for any of the other ones as well or not?
No, I don't think I set it up for the other ones, but let me check to make sure. There are a whole bunch that Michael had that we haven't included yet that have the potential for that. But
like what?
There's like the Yukawa potential and this and that, but those have not really been set up to work with the current framework because I haven't had basically to do that right. I need input from somebody in Michael's group.
Fine, probably Michael himself. What parameters
yes.
By default is spring constant.
Yeah, no, inverse square doesn't allow. Now I could allow a constant there.
Are you doing an association of parameters here?
Well, I set them up as options, so they could be an association. We can process.
Let's okay, so this is equilibrium length. What do you usually call the equilibrium length? L.
L, yep.
I don't like to use L, len. Okay. All right. I mean, this is still an experimental function, and let me just make a note here that we probably want to. Is the Yukawa potential with parameters or not?
Yes, it's with parameters.
No, I mean actually I meant with physical units or not.
I set it up without units because.
I'm just going to put it as a futurized thing just so we remember that.
Okay.
Okay. I mean, there must be tons of other potentials.
Yeah, there was a bunch that Michael had given me, including Yukawa and
Leonard Jones would be another.
Yes, Leonard Jones was there. Let me look and see what else is there.
But Leonard Jones has all kinds of parameters.
Right, exactly. Most of these had various parameters. Yeah, there's Leonard Jones, soft Coulomb, pseudo harmonic, Born-Myers, Morse, and Buckingham.
Those are all good potentials.
Yeah.
All potentials with potential, one might say. Okay. In any case, okay. So let's just try and give the harmonic case. Okay. So you're saying, I mean, it's very yucky that we have to give this. It's very yucky. Let's take a look at that. And I guess that relates to the other function. So let's bring up the other function now.
Well, yeah, it's a little yucky, Stephen, but compared to actually doing the equations and stuff, it's...
No, I understand. But the issue is whether we allow the possibility of the N-body simulation data of just B sub I. Do you get what I'm saying? Because that's the case that is ambiguous.
That's
where you just...
Exactly.
Right.
And we can technically disambiguate it by,
No, we can't.
Putting a floating point as a, a T, 2 dot is a time. That's going to confuse people for sure.
Yes, it's going to fail at some point. So what's a better way? I mean, if we simply said you specify it as N-body simulation data of blah, comma, all, for example, if you just want, what could you have as, or blah, comma, automatic if you want the end case there? You get what I'm saying? See, I wouldn't be horrified if this had to say, at time t, for a body, you want to specify it for all bodies here, right? Oh,
right.
That's what you're giving there.
Right.
Well, the question is which one wins? Is it the body or the time? I mean, we could say all comma 4. That would hardly seem to me dramatically horrible. And in other words, if you give only one argument, it could be, well, which should it be?
I don't think that data of all 4 is unreasonable, because that kind of emphasizes you're getting all the bodies.
Yeah, right. So then that disambiguates. Okay. So what this is saying is we could just say, so here, by the way, this is completely wrong, if I might say so. That you forgot that, right?
Oh gosh, yes. Thank you.
Okay.
Right. The other case we'd have to disambiguate is that next to last one. We should probably just have, the body there is, just get rid of that case.
Okay, hold on. I haven't looked at this for a moment. Okay, so this case here is a little funky.
Yes.
Was that the case you were talking about, or a different case?
No, I was talking about the next, so if we get rid of the T by itself case, we also get rid of it. Right, exactly.
Yeah. So are we getting rid of the T by itself case?
I think we should. Yeah, we just
okay, fine.
All comma T.
Okay. Okay, fine.
And then we can also, I don't think we need to document this. We could support a list of bodies then in that first argument easily.
Yeah, right. I don't see that that's a bad thing to do.
Right.
I mean, why don't we just do that? Okay,
yeah,
so then
I will do that.
Okay, so let's well, then we could just now is it going to give an association like this, or is it going to give a list? I think it's going to give a list in that case. In other words, you get what I'm saying?
Yeah, it should probably give a list. And the fact that it returns an association means that actually, so as your original question, will it accept an association of body rules? And the answer is yes, because I process it in that form.
Okay, because the association gives a list of simulation data, gives a list of simulation data Okay, so comma all, listen, this documentation needs to be cleaned up. It isn't the right way to do it, because comma all for the time should give the whole interpolating function, I think, or should give something that represents a time series. I don't know what you want to give, a time series, an interpolating function. The usual thing for this would be to give a time series.
Well, but yeah, I think an interpolating function is the right thing here.
Okay, fine. But then what is going to be the, if you say comma all, you can't give a pure function as the result. You have to give something that is, that you can just feed right into. You get what I'm saying?
Well, if you just don't give the t, it gives you the interpolating function.
Are you telling me that, or is that a new idea?
No, that's I think that's the way it's always worked.
Okay. So what you're saying is, okay. All right. Represents the result of an n-body simulation. Of an n-body simulation. Okay. Generates an n-body simulation object. Okay. Given, I wonder, do we ever document in this, because really this is useless without, do we ever document the subvalues up here?
I don't think we have. I haven't seen any precedents for that. Because like nearest function as an example.
Yeah, what does it say?
I don't remember, but I think I might have modeled this on nearest function. Yep.
Okay. Okay. Okay, so then what we've got to say is n-body simulation data ... of b sub I gives a function representing the position. Is it correct? Representing the position?
No, it gives all the state properties.
Okay, it gives a function representing the state of body.
Well, it doesn't quite do that. It gives the state where the position and velocity are functions of time. Maybe that's not the right thing. Maybe we should write it as a pure function that.
Let me make a suggestion that we don't document the one argument subvalue case.
I think that's fine.
Okay.
In fact, maybe that's why I didn't do it, because we may have discussed that before and I just forgotten now.
Well, I think that if we don't document that, and you should just have it do nothing, right? Mm-hmm. And then we can figure out what the most convenient thing for it to do is later.
Fine. Mm-hmm.
Okay.
And Stephen, if you look at search result object documentation, it documents all these things in a nice table. If you wanna.
Search result object?
Yes.
Oh, that's an interesting idea.
That's easier to read with the object.
Yes. The only problem is there's a multi-argument cases. Well, actually, this is OBJ.
Yeah, so we just replace n-body simulation data with OBJ.
Right. The following. Okay. Okay, so now you're saying okay. So OBJ, let's call it NBS, just for the heck of it. Or
NBSD maybe.
okay. Of B sub I simulation data, well, state of body B sub I at time t.
Yeah.
Okay. Okay. NBSD of now it's the all case. So let's give B1, B2. States of bodies. Actually, why don't we just say body B at time?
Mm-hmm.
States of bodies B sub I at time t. Then the next case is states of all bodies. Time t. Okay, right. Next case. Okay, so that's those three cases, right?
Yes.
Okay, now next case is a particular property. Or list of properties. It's include only that property, is that correct?
Yes, it includes only that property.
But it still gives it an association.
No, it gives it as without the association. And the reason we came up with that particular thing is that it makes it before we had that the
right,
the plotting stuff was
you're
torture.
Right. Okay.
You could just put, I mean, might even be able to just put $$ to indicate, or bodies. Yeah, that's great.
Bodies, comma, property, value of property prop at time t.
Yep.
Values, doesn't matter, value. Let's do body, let's do B.
Mm-hmm.
Value of property prop for body B, okay, at time t. And then let's list of values, because that's what it is. List of values of prop for multiple bodies at time t.
Mm-hmm.
Okay, now you've got a list of properties.
No, and we didn't support that, because that's really can get that from the association from the first two if you want to list a bunch of different things.
Okay, so I think this case here where you're giving that instead of the bodies of kinetic energy. I think if you want, I think this is wrong. I think we should say all comma kinetic energy comma t.
Fine.
Is that stupid? I mean the problem. No, the problem is that
it involves some notation, because then we'd have to support, say, the kinetic energy for body 1 and body 2.
Yes, that's correct. Okay.
And it
All right.
becomes
Okay.
pairwise
So
energy.
it's that, right?
Yep.
Values of combined quantities. Value of a combined quantity at time t. Okay. Possible combined quantities include.
Mhm.
Now we should say here that it solves the classical equations of motion. NBodySimulation solves classical non-relativistic. Well, by default, solves classical non-relativistic equations of motion.
Right.
Maybe that should be said at the top, since it is kind of critical.
Yep.
Okay, now, possible combined quantities include. Okay, what's this thing here?
So those are just properties of the simulation.
Okay, so that's another thing here.
Yeah.
You know, I'm telling you that the whole business with left-handed people being discriminated against with mice is just terrible. You don't even understand what I'm saying. It's because the things I have to press, because I have a left mouse, I can't hold down key. Well, I can if I really cheat here, but okay. I'm telling you, that's an underrepresented group, left-handers.
Yes. Okay, and then we just need to rewrite that line about the simulation properties.
Yes, I know. Okay. Possible combined quantities include total non-relativistic kinetic energy. Okay.
Oh, I left it dangling. Preposition.
Yes, you did.
Yeah. Bad. Simulation interval, I think.
Total simulation time.
Yes.
Or shouldn't that be just maximum time, total simulation? I mean, it's not obvious to me that you want to start at t equals 0 in all cases, but we'll cross that bridge another time.
We could cross that threshold at some point, but
okay.
Yeah, there are cases. I have cases in the example where it can't simulate to the requested time. because you have a collision.
Right. I think this should reference system model, even though these two things don't quite meet yet.
Mm-hmm.
Okay. All right. So now we were just going to look at the harmonic. Okay. So hold on. We actually got another thing we got to look at here. We got to change this. Right. So you've got to fix these so that they always work this way. Right.
Yes.
And then. Okay. So here, the first case of this. Okay. Hold on. Let's just do this. The first case here will not even give names to the bodies. Right? State 1, state 2, state 3.
Mm-hmm.
Generates a simulation system of n bodies. Okay, that's actually with initial state I, governed by the specified over length of time, over length of time t, over length of time t. Okay. Now here, I think we should document this as an association.
Yeah, fine. I'm happy to do that because then those rules can naturally come out as associations for the.
Fine. Generates a simulation of the motion of a system of n bodies with names body I.
Mm-hmm.
Okay. Okay, nice. All right, so then the minimal case here is a harmonic potential. We can add this example later. Okay, I think we're in good shape here. So the one thing we need to do here is to knit this to other places. Oh, come on, guys. That system model doesn't even, well, I wonder why system model doesn't. System model simulation. Okay, all right, now let's figure out where on earth we're going to put these things on our okay, so there's a number of obvious places to put them. Let's go to guide pages, open main page. Okay, so I can think of some weird places to put them, like in physics. Let's see, physics and chemistry, astronomical science. What about that? Okay. Now that's that place. Let's look at physics. Well, that's interesting. I wonder whether we should include that here. Formulas and models. I guess we can say simulations, and we can say NBodySolve, NBodySimulation. Just for good measure, we can include cellular automaton there.
Sure.
Okay. Molecular structure, we don't need that there. Dynamical systems, where on earth does that link? No, not relevant. Network-based models. Okay, where does it fit in this page about scientific models? I mean, arguably in calculus-based models. I guess we should put it in that page. Is that really right? Dynamical systems. I think it's really right.
Yeah, I think it is right for that list.
Okay, then it probably goes before.
Yeah, I think next NBodySolve is right.
Okay, then it needs to go on bizarrely on the calculus page.
But we don't even have NBodySolve there, do we?
Let's put it at the bottom. And let's point it to NBodySolve.
Mm-hmm.
Well, there is NBodySolve right there at the top, about third row, under numerical calculus.
Oh,
it is there. Okay.
well, then we could put NBody. I guess we could put NBodySimulation there as well. It's a little weird.
Yeah, I'm not sure it fits on this page, honestly. Do we have we must have a page for differential equations in general, though.
I'm not sure. I don't think we have that many functions related to differential equations.
We do. We do. It's guide differential equations. If you scoot down, it's actually linked to this page.
Where?
Scoot down all the way to the bottom.
I'm not seeing it.
Not either.
It shows up under the related guides in calculus, but I'm looking at the.
Oh, there.
Yeah. Right.
Okay. Well, then maybe it doesn't belong on this page.
Yeah, I think it would be better on that page.
Then maybe what we want to say. It's a little weird that it's not on that page. Should we put simulations down here? NBodySimulate?
Yeah, I think that would be fine.
Well, I think we should include system model here.
Mm-hmm.
Okay, so now we've pushed this back here. This is a little weird to have calculus-based models, NBodySimulation, but now, you know what? I'm going to remove that from there, and I'm going to give it its own category. And by the way, does system model appear on this page? That's totally weird. That should be here.
I see systems modeling in the related guides section.
Well, I think it should be on this page. I think it should probably be system model. And then here we should say NBodySimulation, because it's really a category of modeling, I think. I mean, there's probably other things like blades and so on, which is really should be part of this. NBodySimulation, and for the sake of having another thing to put here, that should be a lowercase n. I don't know. That's a DQA question. I don't know the answer to. Okay, here that should link. I'm running out of time here, so that should link to the systems modeling page here. Hopefully that will auto link if I do this. Okay, where else should this go? We put it in physics, we put it in astronomy. Various questions on live stream. Is this function parallelized?
No.
Hopefully it will be one day.
Well, yeah, Mark just added his parareal method for NDSolve, so it's possible when that becomes mainstream, we'll be able to do that.
Can we remember to do it? I mean,
well, it's the method's not ready yet. It's okay. You know, it works, but it doesn't really speed things up.
Okay, let's just think about where else we're going to put this. NBody. I think this is a reasonable set of places.
I think it's, yeah, I mean, as long as, I think the differential equations page is really important, and physics,
okay,
astronomy, that seems to cover it.
Molecular structure and computation.
That's where we're going to want those other potentials, right?
I know, but arbitrary potentials, i.e. you can give them yourself.
Right. Yeah. Okay, fair enough.
Okay, I think that does it. All right,
okay,
so
good.
Got a few more examples to add. Hopefully you can get some stuff in before the freeze today.
Well, that may not be realistic, but I'll just put in bug reports that we don't quite match the documentation.
Okay, I'm going to push this documentation back. Thank you all.
Okay.
Talk to you all soon.
Okay, yeah, bye-bye.
Bye.
Bye.